Okay, in this video, I'm going to go through how to run through the 4-step process for a confidence interval for a population mean. So we're not going to actually be able to do this activity. So I'm going to take some class data I have from a previous year. So we're estimating a 95% confidence interval for the mean number of states an upperclassmen can name in 1 minute. So the sample size was 30. The mean was 17.8 and the standard deviation 5.6. So construct and interpret a 95% confidence interval to estimate the mean number of states an upperclassman at our age can name in 1 minute. So state, we need to state our parameter. So that's going to be mu. Mu is the true mean number of states. And RH, upperclassman, can name in 1 minute. That's it for state. On to plan. C, it says we're going to use this class as a random sample. So we're going to make that assumption that this is a random sample of 30. Variability, we're sampling without replacement. So 30 is less than 10% of all RH, upperclassmen. And shape, we are not using success value because we don't have a categorical variable. So we're looking at the sample size, n equals 30, which is greater than or equal to 30. So the central limit theorem applies, which means our sampling distribution is going to be approximately normal. Therefore, our conditions are met. We're going to do a one sample. This is called a T interval. We're not saying Z interval anymore because we're not using the normal distribution. And we have to include the degrees of freedom. So here we have 30 minus 1, 29 degrees of freedom. All right, on to the do step. So we're going to take our sample mean, 17.8 plus or minus. We need to figure out the critical value with 29 degrees of freedom. So we're going to go to inverse T, and the area is 0.025 with 29 degrees of freedom. So 2.045 is our critical value times the standard deviation from the sample divided by the square root of the sample size. So now I'm going to substitute this in to actually get my confidence interval into my calculator here. So 17.8 minus, no, that's the wrong button, minus 2.045. Let's get a fraction. That's not what I wanted. 17.8 minus 2.045 times 5.6 divided by the square root of 30. So there's the lower bound, and then if I just change this to plus, so 19.89 and 15.71, 1571, 1989. So 15.71, 1989. All right, so there's the do step of our confidence interval. And now we're on to conclude. So we are 95% confident that the interval from 15.71 to 19.89 captures the true mean number of states in RH RH upperclassmen can name in 1 minute. So there's the 4-step process outlined for this that you're going to need to follow for a 1 sample T interval. All right, so let's do a summary. So important ideas that you're going to see here. The T distribution has more variation than the standard normal model. We use the T distribution because we don't know the population standard deviation, and we have to estimate it with the sample standard deviation. Creates extra variability. We went through how to do a critical T value. This is the area in 1 tail. This is a typo. This is not a 1 proportion. This is a 1 sample T interval. State plan to conclude. I have another typo here. My apologies. This is a critical T value. So when you're asked to construct and interpret, we're still following this 4-step process. This has not changed. And there's just the 3 components. There's your point estimate, which is your sample mean, plus or minus your critical value, times your standard error. And the reason we're calling this standard error is we're estimating population standard deviation with the sample standard deviation. All right. So at this point, what I'd suggest that you do is you pause the video and work through this question completely on your own, following the 4-step process, and then come back and watch me work through this. So here goes. As I read through this scenario, I can tell that they're looking at how many scores of toilet paper. It says mu, the true mean. This tells me it's quantitative. The fact that they've used mu and said true mean, huge hints. So I'm going to follow this 4-step process. State. So mu equals the true mean number of squares of generic toilet paper needed to absorb 1/4 cup water. Plan. So the plan is going to look like this. For the center, the random condition, randomly selected 18 roles. So this is a random sample of 18. Always make sure you include that sample size. Variability, 10% condition. 18 is less than 10% of all roles of generic. All right, so the 10% condition is met. We're going to go on to shape. The shape, we have to check the large the large sample or normal condition. Here's all we know. They haven't said anything about the population shape. 18 is not bigger than 30, so we're kind of at a standstill here. What you need to do is you need to plug the data into a list in your calculator and do a box plot. So I'm just going to pause the video here while I do that. So I've got the data plugged into the calculator in a list. So now I'm going to go to second y equals, turn the plots on, and then I'm going to pick the plot that has the box plot with the dots. That'll show outliers if there are any. And I'm going to go to zoom 9, which is zoom stat. So at this point, I can see that there's no strong skewness or outliers. I'm going to hit trace because I'm going to need to know these 5 numbers. The min is 20. Max is 29. So here's what I need to do. N equals 18 is not greater than or equal to 30. So this is the normal large sample condition. So we have 20, 30, 25. And I'm going to construct this box plot. And then I'm going to mention that the box plot is not strongly skewed and has no outliers. So that means we can assume the sampling distribution is going to be approximately normal. Therefore, our conditions are met. We are going to do a one sample t interval, have to name that procedure, and have to include the degrees of freedom, with degrees of freedom equal 18 minus 1, 17. I don't care if you put the degrees of freedom in the plan or the do step, but you do have to include that. All right, moving on to the do step. So I'm going to have to go back to the calculator because I'm going to need some of the summary statistics. So here's what I have. I'm going to run stat calc, one variable stats. I put the data into list 1, so that's where my stats are. So here's what I know. My sample mean is 24.94, and my sample standard deviation is 2.86 approximately. All right, so I have that. Now I just need to get my critical t value, which I could have done while I was looking at the calculator. So second vars inverse t, 99% confidence, so we have 0.5% in each tail, and we have 17 degrees of freedom, and I'm going to paste. So my critical value is 2.9. So I take my point estimate, plus or minus my critical value, 2.90. That's inverse t of 0.005 with 17 degrees of freedom. Is that 2.9 times 2.86 divided by the square root of my sample size. So now I'm going to take and plug this into the calculator to get my lower and my upper bound. So I have 24.94 minus 2.9 times, let's get a fraction for the standard error, 2.86, 2.86 divided by the square root of 18. That's going to be the lower bound. And if I scroll over to get to that upper bound. All right, so we're looking at 22.99, 22.99, 26.89, 22.99, 22.99 to 26.89 is our confidence interval. Right in the middle of that is our point estimate. Conclude. We are 99% confident that the interval from 22.99 to 26.89 sheets captures the, and I'm just going to do this for the sake of time. Go back up to my state step. It is this exact thing. Captures the true mean number of squares of generic toilet paper needed to absorb a quarter cup of water. All right, so that goes through the 4-step process for you. At this point, I'm going to stop the video and make one last part.